In this video, we're going to solve a concave mirror problem. So let's see what the problem gives us. It tells us that SO is 45 centimeters. That's the object distance from the mirror. And remember, we're going to use a thin mirror approximation and say this is the actual location of the mirror. The focal point is a positive 15 centimeters because we're using a concave mirror. The height they give us, or HO, is 4.0 centimeters. Now, let's look at our ray diagrams. The first one is a P ray, which comes in parallel and then goes through the focal point. Then the C, or center ray, which goes through the center and then bounces off. And then the F ray, which goes through the focal point first, then bounces back parallel. We're going to use the thin the thin lens equation to solve for SI, or the distance that the image is from the mirror. So that's the lens maker's equation, as it's called. So we plug in our value for the focal length, which is 15 centimeters, and we have to put it in as positive because this is a concave mirror. That just makes the math work. The SO is 45 centimeters because that's what was given to us, and we're solving that for SI. So if we do our math, we find that SI is 22.5 centimeters, meaning that the object should be 22.5 centimeters from our mirror. And because it's positive, it's going to be on the same side of the mirror as is the object. Then we're going to use this equation to solve for the image height. We know HO is 4 centimeters. That's given to us. We've solved for SI, the image distance, as 22.5. We were given SO as the object distance of 45 centimeters. So we get a height of -2 centimeters. And the reason it's negative is the object is inverted. So it happens to work out that our ray diagrams put our image in the correct place. So the final thing to do is to mention that it's inverted, and by convention we put a negative sign there.